All right, good morning. So today for pre-calc, we are going to be talking about trig identities. Okay, so let me go over a couple of things before we get to them. And then we'll start in on the homework. I'll warn you, this is sometimes a little bit difficult to understand exactly what they're asking for on this one. Okay, I say, what's new? I'm like, no, I mean it. Like this one's actually, it takes some detective work to figure out what they want sometimes. So if you're getting a couple of them wrong because you're like, I don't understand what they're asking here, that's to be expected. Okay, so let me start you off with a squared plus b squared is equal to c squared, right? And if I divide everybody, right, this is the sides of our triangle. See, here's our a, here's our b, here's our c, right? And if I go ahead and divide everybody by c squared, we're going to have a squared over c squared plus b squared over c squared is equal to 1. All right. Now, what's a? A is our adjacent side, right? C is our hypotenuse. So what we're going to do is we're going to write this as a over c squared plus b over c squared is still equal to 1. Okay. All I did was move the squared to the outside. So if I ask you something like, maybe if I share my screen, that would help. Okay, we didn't get too far. Okay, I think we can follow it from here. So sorry about that. So started off with Pythagorean theorem. We divided everybody by c squared. So that's where the a squared over c squared, b squared over c squared is equal. And then we have 1. And all I did was move to the outside here. Just move the squared on the outside of the ratio rather than on the inside of the ratio. And I know we could do this, okay? If I asked you what was the square root of, let's go to 25/64. What is that? And I don't think any of you are going to bat an eye about doing this, or 64 rather, which is 5/8. And that's what you're supposed to do. So we can move the square root, we can move the exponent to the top and the bottom, okay, independently, and then go ahead and evaluate. We can move the exponent from the top to the top and the bottom. We could move it to the outside, just like going and doing this backwards. Okay, so we're allowed to do that. Now, a is our adjacent side, c is our hypotenuse. What trig function, what trig ratio is going to be the adjacent over the hypotenuse? And that's going to be cosine. Okay, cosine of an angle. Plus b is sine. Okay. Oops, let me do it this way. We're not there yet. Cosine x squared. Okay. B was sine. Okay, b over, it's opposite over hypotenuse, so that's going to be plus sine x squared, and then we're just going to leave that as a 1. Okay. Now, the way you're supposed to write, the way you can write cosine x squared, okay, because this happens a lot. So we have a little bit of a shorthand, and we move the square on the inside. Okay, and that's a very common and recognizable notation. Okay, so if you have cosine to a power first, so what if we did like something like tangent cubed? What that would mean would be tangent x cubed. Now, most of the time, it's easier to write it in this notation, but occasionally if you're solving a problem, you're trying to factor something or see a pattern, and you end up writing it this way because you're trying to see something, that's fine. Okay, there's nothing wrong with either of these notations. Okay, so use the one you prefer, but understand that most textbooks, most people are going to be using this notation first, and then when you actually have to factor something out, they're going to change it to this notation. Okay, so that's how that's used. Okay, and this is one of the primary Pythagorean identities. Okay, Pythagorean identities because we came from the Pythagorean theorem. This is something you should remember for the rest of your life. Okay, for as long as you're going to do any math whatsoever, this is something that's going to be in your head. All right. So I had a teacher that used to say things like, there's formulas you memorize for the test, and then there's formulas you memorize for life. This is a formula you're memorizing for life. Okay. There's 2 more. What if I divide everybody here by cosine? Okay, so what if we divide we divide all terms by cosine squared. All right. So we're going to have cosine squared x over cosine squared x plus sine squared x over cosine squared x is equal to 1 over cosine squared x. Oh, what's a fancy way to say cosine squared over cosine squared? That would be 1. Okay. Sine over cosine, that's tangent. We have 1 over cosine, which is secant squared. Okay, so this is another formula. It's also a Pythagorean identity. All right, and then we'll start back with cosine squared x plus sine squared x is equal to 1. And what if we divide everyone, right? Divide all by sine squared x. So there's going to be sine squared x, sine squared x, sine squared x. Cosine squared over sine squared, that's going to be cotangent squared. Plus sine squared over sine squared is 1, and 1 over sine squared is cosecant squared. Okay, and that is yet another Pythagorean identity. Okay, so technically the class, the book, the expectation is that you would know all 3 of these. Okay, I never memorized the second one, nor did I ever memorize the third one, because I knew how to get them from the first one. Okay, because there's going to be a lot of memorization in these next couple of sections. Actually, most people will call it sine squared over cosine squared. That's just the order that they tend to write it in. But you guys can swap you're allowed to swap. And then we have tangent squared x plus 1 is equal to secant squared. And then you have cotangent squared plus 1 is equal to cosecant squared. Okay. So this is the order they're typically written in. Okay, this one is hyper important. Like you have to know this one. Okay, there's no ifs, ands, or buts. You have to know this one. If you say, well, I'll memorize one of these, but not the other one, this gets used like more often than this third one by a lot. But every once in a while, you're going to need this one too. Okay, so we'll do a 3 exclamation point. So we'll do all right. So this first one, like log rules, like the last thing, if you're going to suffer from Alzheimer's, like this should be the last thing you forget. Okay, before lights out. The second one, okay, it gets used pretty often, not nearly as much as this one. And this third one gets used about half the amount of time that this one. So if I was going to look at it, like 90%, 10%, or 85%, 10%, 5%. Okay. And I know that that's wrong, but because this is like way more often than 85% of the time. Okay, you almost always use this one, and occasionally this one, and then rarely this one. Okay, but you're going to have to memorize at least this first one. And as long as you remember how to get to the second 2, you're going to be okay. All right, because I've always had time to be able to kind of figure out, like, what's that one again, and then check. So that's one of the things that we're going to be looking for. Okay, and then we also have like some things that you kind of already know, that sine x is equal to like 1 over cosecant x. Okay, or cosecant x is equal to 1 over sine x. Okay, these are called reciprocal identities, and there's all of these as well. There's 3 pairs. Okay, cosine x is equal to 1 over secant x, and secant x is equal to 1 over cosine x. Okay, and then of course the tangent. Okay, so those are reciprocal identities, and these are another one that you kind of have to know forever. All right. but I think you've had like some experience with this so far. So yes, you do have to know them. I don't know how much of a struggle it's going to be to memorize that these are reciprocal functions. Right, and then we have even and odd. Right, you guys remember learning about even and odd functions in algebra? Right, so an even function, there's symmetry about the y-axis. All right, so that's going to be that means that here's the test. If you plug in negative x, you get the same thing. That means stuff over here, whatever the y value is the same as stuff over here, whatever the y value is. Okay, so that's the symmetry about, that's even symmetry. Okay, that's symmetric about the y-axis. Cosine is an even function. Okay, sine and tangent, those are both odd functions. So this is the test is f. Let's go ahead and title it odd function. That is f of negative x is equal to negative f of x. Are we factoring out the negative? Like, no, we're not doing that. We're applying this type of symmetry, which allows us to do this. This is the definition of an odd function, that it has this property. So we're not factoring the negative sign out. I know it looks like it, but that's not what's happening. All right. So odd functions, right? F of negative x equals the opposite of f of x. Okay, so if we've got something going on over here, then f of x and negative is going to go something on over here. Okay, so that's what happens. Whatever's going on in the quadrant 1, it has to be going on in quadrant 3. If it's going on in quadrant 2, it has to be going on in quadrant 4. Okay, things like 1 over x, that's an odd function. Right? So stuff that's happening over here, right, has to be going on in quadrant number 3. Right? So sine and tangent, those are both odd functions. Okay, so 2 other identities, or 3 other identities, cosine of negative x equals cosine of x. You can think about like the cosine just eats the negative sign. And then sine of negative x is equal to negative sine x. Okay, so the negative sign passes through, not because we're factoring it through. Okay, we're not distributing it. Okay, it's because it's an odd function. Okay, same thing with tangent. Tangent of negative x is equal to negative tangent of x. All right. So those are 3 other identities, properties you have to know. All right. So Pythagorean identities. Okay. Reciprocal. Okay. And even odd. Don't worry, there'll be more in section 5.2. All right. So there's a lot to know. Pythagorean ones you have to know forever. Reciprocal ones you have to know forever, and it's really easy. It's really convenient to know which ones are even and odd. Okay. When you get to calculus, they'll show you how to approximate sine and cosine, and then tangent. So that's another one where if you have this knowledge coming in, it'll make that part of calculus a little bit easier. Okay. Actually, this is going to make almost everything a little bit easier if you know these really well. Okay. So the other thing about identities is that we're going to have something that seems to be equal to each other. Okay. Let me do something here for us. I'm going to pause and I'll bring this up. Okay, I really just didn't want you to see that I don't exactly know how to get to the library webpage, and it takes me a moment to do that. There is an additional book, okay, called Trig or Treat. Since it's close to Halloween, that's really appropriate, right? So I went to the CNN library page. Okay, so if you go to, I just when I went to CNN webpage, I just searched for library. and it brought me here. I was like, perfect. So here is my, so it didn't quite bring me here, but it was, yeah, I guess it did because it has the hours. And then here's my search value. So since I knew the name of the book, it's called Trick or Treat. Okay, I typed that in and press search. Okay, and then my web page came up. So this is an entire book full of, see, an encyclopedia of trigonometric identity proofs. They have the answers and they'll show you how to do it. Okay, and there's dozens of identities here that you get to prove, and they graduate them. So they have like an easy, medium, hard type of a section for it. Best off, it's an ebook, so there is no excuse. You guys can all check this thing out. You can all look at it. Okay, now it's going to do that. Hold on for a second. Pausing again. I want to put my password up on the internet for everybody. It hides it, but I wasn't sure if that was going to happen. All right. So here's our book. Okay, and you can go through, and they've got some preamble stuff. Okay, which you're welcome to read. It gives you some little hints about how to set these things up. Okay. Okay. But you want to go down to like one-on-one games. You want to go to the level 1 games here. Talk about easy proofs. Okay. I like this less easy and not so easy. It's cute. All right. So they're going to give us something like this. Okay, like 1 plus sine A over 1 plus cosecant A is equal to A. So I just wanted an example to kind of guide us about what we're talking about. We're not going to do it. No, we could do it. Okay. So we have 1 plus sine A. Okay. In Europe, they don't really teach secant and cosecant or cotangent, really. So they have like slightly different notation. Some books use slightly different notation. So I think they just wanted to be really sure that this was going to be cosecant here. We abbreviate cosecant with this. Okay. But they use something a little bit different. That's okay. We say that that is equal to sine X, or sine A rather. Okay, these are both A's. Okay, the rules are you have to pick one side or the other side. I'm recommending picking a side that has like more stuff to do, okay? But you have to pick the left side or the right side to work this. You may not set them equal to each other and like cross multiply or anything like that. You effectively don't have another side. So the things you're allowed to do is you can either add 0 or multiply by 1. Okay, you can change forms, okay? But you can't set them equal and then show that they're true. It's not always the easier side is going to be on the left. Your book tends to make it that way, but that's not always going to be the best way to go. You are going to have false starts. You're going to do something, you're going to run into a dead end, and you're going to have to restart. That's normal. As a matter of fact, if that never happens to you, you're being way too careful about things, okay? Or you're peeking or something. But it is very normal that people will start with one side and get stuck and then try to do the other side and then maybe get it. But you're not allowed to like set them equal and then prove it, okay, or show that they're equal. Okay, you have to start from the left side and work down until you get to this one, or multiply and divide by stuff on this side and get down to what's going to be on the left-hand side. Okay, so that is the rules for doing trig identities. If you show me that you set them equal to each other and cross multiplied or anything like that, that's not really a passing score. Okay, so just understand that. I'm not saying you're getting no credit, but I am reluctant to want to pass you if you've broken those rules. Okay, so we get to do different things. Okay, and so in order of things that you might want to do is get common denominators. Okay, one of the most powerful things you can do is change all ratios to sines and cosines. Okay, that's one of the most powerful things you can do. Trying to think of another one that they could do. But can common denominator, oh, multiply by conjugates. Okay, so there's a number of things that we can do with it, but if you're stuck, okay, these will often get you unstuck. Okay, so okay, common denominators and figure something out from there. Multiply it by something clever, some conjugate, okay, or change everything from sines and cosines. And honestly, this has been the most helpful one as a strategy to solve these problems. Okay, so I'm looking at this one and I'm like, yeah, I'm not really sure what I want to do with this. So I don't really want to multiply by a conjugate. I don't know. Maybe. Okay. But my first thought might be something like, why don't we change our cosecant to a 1 over sine? Okay, so we could say this is 1 over sine A, 1 plus 1 over sine A. Okay. Now we could try to get something like a common denominator here. So we're going to say this is sine A over, well, hold on. I don't want to mess with the top of my fraction just yet. Okay, so we've got a 1 plus sine A here. And then here on the bottom, I'm going to try to set up to get a common denominator. So that's sine A over sine A. So that's what my 1 plus 1 over sine A. Okay, just writing this down. Now that we have a common denominator, we can add. So we get 1 plus sine A divided by sine A plus 1 over sine A. Okay, and this is equal to, okay, this is equal to 1 plus sine A, technically over 1, divided by sine A plus 1 over sine A, because that's how we deal with a compound fraction. Okay, what do you do when you're trying to divide by a fraction? Well, say that is equal to 1 plus sine A over 1 times sine A over sine A plus 1. Are these the same? They are the same, aren't they? So what we're going to do here is we're going to cancel these guys out. Okay, and then we're going to have equals sine A. What were we trying to prove? Oh, that this whole thing is equal to sine A. So we have sine A is equal to sine A. We're done. This was the right-hand side. So we're set. Your book doesn't like to lie to you, at least not too much. Okay. So when they say something about verifying an identity, you can usually be assured that that identity is going to be true. So if you can't get it, you've made a mistake somewhere along the way. Okay. Now, that's not always going to be the case, because like more difficult books, maybe later sections, they are going to lie to you. They're going to say verify it. You're like, I can't. So you lied to me when you gave me this problem to verify. Okay, but this is a really good book for. See, look at this. They tell you, hey, what if we do some of these things? Okay, and they'll go through and they'll kind of show you, okay, what the hint is, and they'll give you progressively more and more hints as you go through it. Okay, so this is a really good book as far as like figuring out what's supposed to go on here. See, right here, it's okay, it's that. I didn't peek, I don't know. Okay, and then they went through and they redid this and then divided, and then we're good. Okay, so that's how they can go. So there are dozens upon dozens. Yeah, they change it. Tangent is equal to sine over cosine, and they just start using abbreviations rather than writing the whole thing out. You should write the whole thing out. Okay, just saying. But Yeah, see, you should always write out the trick. So when you're going through this, if you're just making a note to yourself, like how I'm going to do this, like I'll never say it. I don't care if you write sign. I do it too, right? Like, I don't know what I'm going to do. I'll quickly sketch out a solution or sketch out a couple of steps, what I want to do with just abbreviating. And then when I go in to write it down, I'll refill it in. But I'm just kind of like giving you an idea of like what's going on with this book, because if you peek, right, your spoilers, they'll show you how to do it. Okay. And the reason we picked your book was because it had a better trig identity section, and you have more freedom to do some things than all of the other books that we had. They were all multiple choice, like which proof do you think is right? And when you get started in the trig here and start getting frustrated, just understand this was the best option we had. All right. So that just lets you know what the other options were going to be. So when you find yourself cursing Connect Math, like, I wish this was better. Now you realize it was the best one we had. This was the best choice. Okay. This has been a video. I think it's 30 minutes or something. So I'm going to go ahead and stop. And in the next video, we can start going through some of the problems that Connect Math has given us. Okay. We can go through some of these. Well, there's a lot of problems. All right. So until then, I'm going to let this go, and we'll get working on that. All right. Thank you.